Hello guys, next tutorial what we have is called as Diffie Hellman. Now what is Diffie Hellman? It's a key exchange algorithm for symmetric cryptography. Now in this what we have is let's suppose we have two person, they want to exchange the keys, right? Both the keys should be same. Now to do that we have an algorithm called as Diffie Hellman. Now to implement Diffie Hellman, we'll name this class as DH for Diffie Hellman. Okay, we'll remove this. Okay, we require a main function, so this is your main function. Now what we have in this is, I hope you know the theory part of this. So if you're not aware of the theory part, so you will find a link below for Diffie-Hellman theory. Okay, now how it's implemented is we have two people, A and B. They want to share a secret key. For that they have to do some calculations and some value exchange, so that they will come to a conclusion of two numbers, right, or two keys. Now so for that, first we need is two person A and B. Then both will select a secret key called as X and Y. Then after some calculation they will get K1 and K2, and both this value will be same. Now, to implement this concept, we will take input from user. So what we'll do is again, let me take input from user. We can take input from user using scanner class. Again, you can use buffer reader or you can use scanner class, it's your wish, but for this example scanner will be very easy to implement. So we'll say scanner std standard input and new scanner system.in. Again, we have to import the package, so the package is imported. Okay, now we require variables, right? We require variable like, so we'll declare a variable n, we'll require variable g, then we'll require variable x, will require y, will require what next we require, yeah, so we require this variables, right? Again, we require k1 and k2, so we'll require k1 comma k2. Now the problem is, in future it's sure that we have to okay, we have to do calculations, right? One of the calculation is we have to calculate the value of A and value of B. Again, we require two more variables here. This time we'll go for capitals, because in algorithm we have in theory part we are going for capital A and capital B. Now in future we have to calculate value of A as g raised to x mod n, right, and B as g raised to y mod n. That means we have to do operations of power and mod. Now for that we will not doing that operations, we will ask Java to do that operations, right? And that means we have to use some methods, and to get those methods, instead of using int, we'll use a class called as big integer. Now big integer is a class in Java which offers you certain features like power, mod, and the value of your integer can be big, because the problem is when you go for the power, it will give you a big number, and to store that big number, int is not enough, and that's why we require a big integer. So we'll import the class, yeah, it's java.mat.biginteger. Now we have to initialize all these variables, right? So we'll start with two values of, first is g and n and g. We will ask user to enter this detail, so we'll ask user, so we'll say enter two prime numbers. So we'll store that number in n and we'll store that number in g. So g, n equal to some value and j equal to some value. So we'll say new big integer. So to create an object of big integer, we have to say big integer, and this you have to say std in dot next. So using next you will get the value. Same goes for this one. So it's new big integer, and here it will be std in dot next. Okay, now what next? Now we'll ask a user A to enter the value of k1, and we'll ask a user B to enter the value of y. So we'll start with A. We'll ask A, like we'll say person A, enter your secret number. Then he will enter the secret number, so we have to store that number in x. So we'll say x equal to new big integer, and we'll say study in dot next. Now once you got x, then we'll find the value of yeah, using x we will find value of a, right? So a equal to, you will say we have g will be, to find the formula of g raised to x mod n, we have a function called as mod power, which will accept two values. One will be x and second will be n, right? So by this you will get a value of a. Okay, now a will send this value to b. Then what next? We'll ask b to enter his details. So we'll copy this statement. In fact, we'll copy everything because we have to do the same task here. This time instead of a we'll say b, instead of x it will be y, instead of a it will be b, instead of x it will be y. So a will calculate g raised to x mod n and b will be g raised to y mod n. Now once you got the value of a and b, a will send a to b and b will send b to a. That means a will calculate k1 now. So k1 will be equal to, it will be your a, it's about, the formula is a raised to y mod n, right? So it will be mod power, you have to pass b, formula is wrong. To find the calculator value of k1 we have to use b raised to x. So mod power, it's b raised to x mod n. So this is how you will find k1, and then you have to find k2, which will be a raised to mod power, this will be b raised to y raised to n. Now once you got the value of k1 and k2, both should be equal, right? So let's check. So we'll say A's secret key is, we'll print here k1, and we'll say B's secret key, which will be k2. Okay, and you should get the same values, right? So if we are getting the same value, that means the code is done. Let's run this code now. Asking for a 2 prime number. So as you know, the book example, we have number 11 and 7. Now we'll enter maybe 2 and we'll enter 6. See, both k1 and k2 is 5, right? So this is Diffie Hellman algorithm. By this they have exchanged the value of k1 and k2, both are same. And that's it for this video. For next video, stay tuned and do subscribe. Thank you so much.